Hi, welcome to Engineering 160A, Studio Session 3.3, the tutorial objectives. We're going to build upon our waveform generator VI to include the ability to generate other types of signals in addition to a sine wave. We will learn the LabVIEW math script window, which is a graphical user interface similar to MATLAB and will help in developing math script code. We will also explore the use of enumerated controls, which allow a programmer to associate text with integer values. Our current program has the ability to generate a sine wave at a user-defined amplitude and frequency. We will now include the ability for the user to choose between a cosine wave, a DC level constant value, a square wave, and lastly, a user-defined function. Back to LabVIEW. Let's take a look at LabVIEW's math script window by going down to Tools and then Math Script Window. This will pop up a window that looks similar to MATLAB. Here you see we have our command window. Let me try to simply generate a sine wave. Let me define t as going from 0 in increments of 0.01 all the way up to a value of 0.99. When I hit enter, you see in the output window I've generated my different time steps. I go from time 0 all the way up to time equals 0.99 seconds in increments of 0.01. And this gives me, up here under my variables tab, tells me I have now some variable t, which is a 1 by 100 array. Well, let me generate the sine function just like before. I have x is equal to 5 times the sine of 2 times pi times the frequency, we use 4 times time t. And I hit enter. I can simply plot this by just saying plot open parentheses t comma x and hitting enter, and it pops up my sine wave with a frequency of 4. If I wanted to figure out how to make a cosine wave, and if I have my cursor in the command window and I hit the up arrow key, it will bring up the previous lines that I've already written. Go to the line where I defined x, but instead of having a sine wave, let me now determine the cosine, and I hit enter. So now I've redefined what x is. So I can go back up to my plot command, hit enter, and now you see that I have plotted a cosine wave. LabVIEW's MathScript node has a lot of already predefined functions, and we're going to use these to help us generate our other types of waveforms. If we want to see a complete list or need help with the syntax of our math script, all we need to do is type help space classes and hit enter, and then a LabVIEW help window will pop up describing all of the different functions. To generate our different waveforms, there's a multitude of commands that can help us under this waveform generation. So let me click on that, and we'll see there's a bunch of commands that are already built in. We can easily generate our DC signal or creating a constant value with time by using this linRamp function. So let me click on that and see the description. The description says it generates equally distributed samples that lie between two values. These values are A and B, which are the inputs. Lastly, we have another input listed here as N, and that specifies the number of samples to generate. So if we want to create our DC signal and we use linRamp and we set A equal to 4, B equal to 4, and N equal to 100, this will generate 100 different points, all with the value of 4. Let's see how the linRamp function works. Let's see if I can change how I described t. So t, remember, goes from 0 to 0.99 in increments of 0.01, which was 100 different elements. Use linRamp and say vary linearly from 0 all the way up to 0.99, and then give me 100 elements. And when I hit enter, we'll see that I have the same exact range of t as I had previously, but now I've used the linRamp function. So if I want a DC value, let me say that the x, if I want it just to be a constant, I can kind of use this linRamp to fool it to make everything the same value. linRamp, open parentheses, and let's say I want a DC value of 4. So I can say, okay, start at 4, end at 4, and give me 100 elements. This will create an array of 100 elements where every element has the value of 4. So now if I go plot t comma x, I should get DC signal which has a value of 4. generate my square wave, we're going to use another function that's built in. So let me go back to my help menu, in my command window, help classes, and I'll go back to waveform generation, and there's a signal generator here, gen signal, which says periodic signal generator. Click on that function and we'll see it says you can put in the type of signal you want, the period, the duration of that signal, and the interval, and it will output the associated value of x and the value of the time which we have been generating. And the types of signals that we can generate are a pulse, a sine wave, or a square wave. So let's see how this function works. Let me go back to my command window and let me say x is equal to gen signal. The type, it told me to put in quotes the word square if I wanted a square wave. The next thing was the period. So let's say I wanted a frequency of 4 again, just to stay consistent with what I was doing earlier. That's a period of 1/4 or 0.25. I want the duration or the total time to be that 0.99 seconds. Lastly, the interval, 0.01 second. Close the parentheses and hit enter. And it has generated for me this square wave that I can now plot t comma x square wave. So now I want to use these functions and everything I wrote in the command window we can integrate into our MathScript node script, which is inside our block diagram. Before we modify our script in our block diagram, let's first take a look at adding shape options with our enumerated type control. So when we go to the front panel, if we right click, there is a subpalette called ring and enum, and we can go down to enumerated control. We can grab that and place that down, and I'm going to change the default name to say shape. This enumerated control type is going to allow us to put in text and have the computer associate that text with a specific numerical value. To make our text associations, let's hover over our enumerated control, right click, and let's go down to edit items. When I do that, a window pops up, and under edit items you see I have no items listed. To make an association, let me go to insert, and the item is going to be named sine. Sine is now going to be associated with the value of 0. Add another one by hitting insert again, and I can write cosine. And if I wanted to move where this was, I can go move down, okay, and that will make sine have a value of 0 and cosine a value of 1. Another one, DC level, and let me move this down. It's going to have a value of 2. I'll create a fourth one, and I'll call this square. That has a value of 3. I can double click under here to create another one instead of hitting insert, and I'll just type user defined, and that will be associated with the value of 4. So now let me hit OK to save all of this. And now you'll see inside my shape enumerated control, a user can select sine wave, user defined, square wave, DC level, or cosine. Let me pull this all the way out. If I wanted to be able to see the numerical value that sine is associated with, I can hover over, right click, and go down to visible items, and I can click or toggle on here digital display. Now it's time for us to start working on the block diagram. The shape is going to associate the different waveforms that we want with numbers, and we want this as an input to our code. So let's right click on the left side of our MathScript node, go to add input, and I'll call this S for shape. Now let me plug in my shape enumerated control to that value of S. Now that my value of S is associated with the different shapes, I can use Boolean programming or true-false sort of statements to be able to properly generate my waveform. So how are we going to do that? Well, modify the code to, after we create our time array, to say if the value of S is equal to 0, that means we want a sine wave. And this double equal sign makes it a Boolean or a logical statement that says, is it true or false? Is S equal to 0? If it's true, then do what's next. And what's next is going to be generating a sine wave, because if it's true, we said that 0 is associated with sine. So let me put a couple of spaces here just so it looks separated. And if that's true, I generate my sine wave, so that's pretty good. That's the sine wave there. And if it's not, so if you get a false, it's going to skip creating this x here and do something else. Well, what is that else? You type else if s is equal to 1, again, this Boolean true false with a double equal sign. Well, if it's equal to 1, we want to generate a cosine wave. X equal a times the cosine of 2 times pi times the frequency times t. Okay, if that's not true, else if s is equal to 2, then we want to generate a DC signal. So then calculate x as such. X is equal to that Lin ramp where it's going to be that constant value where it's the amplitude, start at the amplitude, end at that amplitude value, and give me a total number in my array of n, or the total number of points. Else if s is equal to 3, x is then supposed to be a square wave, so x is going to equal the amplitude times gen signal, open parentheses, square, close quote, comma, in its period, which is just 1 divided by the frequency f, comma, its stop time, which we labeled here as stop, and lastly the increment change, which we labeled as, or defined as, step above. So let me move all these over, and let me close my parentheses. Hit enter. We have one more, else if s is equal to 4, then we want to define x such that it is equal to some sort of user-defined function. Right. So for argument's sake, let's just say this is a combination or the addition of a sine wave and a cosine wave, different amplitudes and frequencies. So I'll just say it's 4 times the sine of 2 times pi times, let's give this a frequency of 4 times t, and then we want to add to that a cosine wave which has a amplitude of 2 times the cosine of 2 times pi times, let's give this a frequency of 2, and then multiplied by t, close parentheses. And then lastly, we have to end our if statement, so we have to type the word end. Okay, we see our program still has an error here, so let me click on that and see what it says. It says you have connected 2 arrays of different dimensions. To help me figure out this bug, let me go back to my LabVIEW math script node window, and let me bring back up x equals the generate the signal for the square wave. I'll hit enter, and what I'll see is x was created using that pre-built function to be a 100 by 1 array, yet all of the other signal creations, like when I did Lin ramp, okay, so I'm going to, instead of calling it x, let's call it x Lin, so we know this is created from Lin ramp, and I hit enter. That is a 1 by 100 array. So it's just the way that LabVIEW has generated the values. One is a row array and the other one is a column array. So we actually need to transpose the x values that were created using the gen signal function to be a 1 by 100 as opposed to 100 by 1. And to do that, we can just use the pre-built function transpose. So back on my block diagram, I just want to add the command transpose, open parentheses, and then go to the end of that line and close the parentheses for that transpose function. And now you see, once I've made those edits, my run button is back. Now if I go to my front panel and continually run the program, we can see that I can generate a sine wave with amplitude of 5 and a frequency of 50. And I can easily change this to a cosine wave. I can change the amplitude of that cosine wave, create a DC level, changing the amplitude, and a square wave. I can play with the amplitude and the frequency. And that concludes our Studio Session 3.3.